guys, I am back with the third video of Quadrilaterals class 8 maths, and in this video our focus would be on types of quadrilaterals and also properties of different quadrilaterals. In fact, we are also going to spend good amount of time in understanding parallelograms. Yes. So this is Roshni from Learno Hub, where you can learn math, science, English, tips and tricks, and each and every concept like never before. So are we all ready? Let's get started.
Let us now discuss about the types of quadrilateral. Now, as I had mentioned before, that there are many different types of quadrilaterals based on the values of the angles and the values of the sides. Now, whether their sides are equal or not, parallel or not, whether their angles are equal or not, based on that they have been divided into so many different types. So the first type of quadrilateral that we will talk about is a trapezium. So here this is what you see as a trapezium. This is how a trapezium looks like. Now, how do you know that which quadrilateral is a trapezium? So the most important feature of trapezium is that one pair of sides are parallel. Now, when I say one pair of sides are parallel, of course, these sides have to be opposite sides, because adjacent sides will never be parallel. They cannot be parallel basically, because adjacent sides, they meet at a point, so they can't be parallel. So here only one pair of sides will be parallel. That means one pair of opposite sides. Like in this diagram, you see this side. Let us name this A, B, C, D. So in this diagram, we see that AB is parallel to CD. So at least one pair of sides need to be parallel. So that is the most important characteristic of a trapezium. Now, a trapezium can look in many different shapes. Like one shape is shown here. This is also a trapezium, something like this, because here also if you see this side and this side, they are parallel. So this is also an example of a trapezium. Similarly, when you look at this is also a trapezium, because you have at least one side parallel, one pair. It is not necessary that only one pair has to be parallel. It is something like at least one pair of sides should be parallel, and obviously those sides are the opposite sides. So that is a trapezium. The next type of quadrilateral that we will discuss is a parallelogram, the most common type of quadrilateral, because in parallelogram itself we have many different types of parallelogram again. So parallelogram, it has the word parallel in itself. So here in parallelogram, two pairs of sides are parallel. So we can actually say that the opposite sides in parallelogram are parallel. So this side, let's again name it A, B, C, D. So in this case, AB is parallel to CD and AB is also parallel to BC. So both the pairs of sides are parallel. So both opposite sides are parallel. Now here not only opposite sides are parallel, here opposite sides are also equal. So the opposite sides are parallel and the opposite sides are also equal. So these are the two features which distinguish a parallelogram. The third type of quadrilateral that we will discuss is a kite. The kite is a very known thing, I'm very sure, to all of you. So you see this shape is also in the shape of a kite. Now what are its properties? Here two adjacent pairs of sides are equal. That means adjacent side, this side and this side. So lengthwise these two are equal. Similarly these two are equal. So here two adjacent pairs of sides are equal. So that's the most key property of a kite. So we can say here in this case AB is equal to AD and also BC is equal to CD. So this is what distinguishes kite from other quadrilaterals. Now kite can also come in many different shapes. Now something like this. if a diagram is drawn like this, where this is equal to this and this is equal to this, so this is also a kite, because you have one pair of sides equal, again you have another pair of adjacent sides equal. So a kite can look like this as well. So always do not go just by the look of the quadrilateral. Just by looking at the quadrilateral, do not decide whether it is a parallelogram or a trapezium or a kite. Look for the properties of that image to decide what it is. So now that we have discussed three important types of quadrilateral, let us start discussing parallelogram in more detail. So we will talk about the properties of parallelogram. So as I mentioned before, in parallelogram, the opposite sides are equal, that is, this is equal to this. Again, let's name this, that makes it easier. So when we say opposite sides are equal, we mean AB is equal to CD and also AD is equal to BC. Opposite angles are also equal, that is, angle A is equal to angle C and angle B is equal to angle D. Adjacent angles are supplementary, that is, sum of the adjacent angles is equal to 180 degree. Now two angles are said to be supplementary if their sum is equal to 180 degrees. So we can say that, looking at this picture, angle A plus angle B is equal to 180 degree, or we can say angle A plus angle D is equal to 180 degree, or we can say angle B plus angle C is equal to 180 degrees. So any two adjacent angles, their sum will be equal to 180 degrees. Diagonals bisect each other. So if you draw the diagonals of a parallelogram, so one diagonal divides it into two triangles. Now if you draw both the diagonals, you see that the diagonals bisect each other. Now when I say bisect each other, that means they meet at a point such that this point divides the diagonal into two equal halves. So basically this will be equal to this, or this will be equal to this. So when we say diagonals bisect each other, that would mean AO is equal to CO and BO is equal to DO. So that is the meaning of bisection. So when a line is bisecting another line, that means it is dividing that line into two equal halves. So these are the properties of a parallelogram. So now we will spend some time trying to prove each of these properties, because I just told you that these are the properties, but why should you trust me just like that? So let us try to mathematically prove each of these properties. So let us start with opposite sides are equal. How do we know that opposite sides in a parallelogram are equal? So now in order to prove this, that the opposite sides in a parallelogram are equal, what we would do is we would draw a diagonal to this parallelogram. And also let us name the parallelogram. Let's say this is ABCD, a parallelogram where BD is a diagonal. So now what do? Now we will compare these two triangles. So let's see. Triangle ABD and triangle BCD. So in these two triangles, what do we see? Now in a parallelogram, we know that the opposite sides are parallel. That is why it is a parallelogram, right? So let's also name these angles. Let us call this angle 1, angle 2, angle 3 and angle 4. Now since these two sides, since AB is parallel to CD, so that is something which is known to us, because that is a part of the definition, that parallelogram is a quadrilateral with opposite sides parallel. Now since they are parallel, therefore angle 1 will be equal to angle 4, right? The angle 1 and angle 4 will be equal. Similarly, angle 2 would be equal to angle 3, because BC is also parallel to AD. And when you compare these two triangles, you see that BD is equal to BD, which is a common side. Now considering these three parameters, what do you see? That two angles and one side are equal for both these two triangles. Now as per our knowledge on congruency of triangles, we can say that triangle ABD is congruent to triangle BCD. By which rule? This would be ASA, that is angle side angle congruency, where two angles and a side included by these angles are equal in both the triangles. So therefore these two triangles are congruent. Now whenever two triangles are congruent, then all their corresponding sides and all their corresponding angles are also equal. Now since these two triangles, now this triangle and this triangle are congruent, therefore this angle A will be equal to this angle C. Therefore, angle A would be equal to angle C. That is, opposite angles would be equal. And also, AB would be equal to CD. That is, opposite sides will be equal. So, this is what we wanted to prove, that opposite sides in a parallelogram are equal, and we proved it. Let us now try to prove that opposite angles are also equal. In fact, we almost proved it in the previous slide, but okay, let's see it once again. So again, let's name the parallelogram. It's ABCD. We draw a diagonal AC. Let's also name these angles. Let's say this is angle 1, this is angle 2, this is angle 3, and this is angle 4. Now, what are the things that we know? We know by definition of parallelogram that AB is parallel to CD and BC is parallel to AD. This is something which is known to us. And we want to prove that angle B is equal to angle D. They are the opposite angles. So we want to prove that angle B is equal to angle D. So what do? Again, we compare triangles ABC and triangle ADC. And we find that since AB and CD are parallel to each other, therefore angle 1 is equal to angle 2. Since BC and AD are parallel to each other, therefore angle 3 is equal to angle 4. And AC is equal to AC, which is a common side. So therefore, considering these three parameters, we see that triangle ABC is congruent to triangle ADC by ASA congruency. Now since these two triangles are congruent, therefore their corresponding angles are also equal. Therefore angle B is equal to angle D. Now, in case you have any questions in your mind like this, that okay, these two triangles are congruent, but why did angle D become equal to angle B? That's because if you look at the other angles, angle 1 is already equal to angle 2, angle 4 is already equal to angle 3. So you are just left with one angle in this triangle, which is angle B, and you are left with one angle in this triangle, which is angle D. So therefore angle B will be equal to angle D, which are nothing but the opposite angles of the parallelogram. So this proves that the opposite angles are equal. So let's now try to prove that the adjacent angles are supplementary. That is, sum of the adjacent angles is equal to 180 degrees. So for this, again, we consider this parallelogram. Let us label it as ABCD. And here again, we draw a diagonal AC. Let's also label the angles. Let's call this angle 1, this angle 2, this is angle 3, and this is angle 4. So now let us consider any one triangle. Let us say we consider the triangle ACD. Now we know that sum of the three angles in a triangle is equal to 180 degrees. Therefore we can say angle 1 plus angle 4 plus angle D is equal to 180 degrees, right? Now when you look at this, angle 1 is equal to angle 2. That's because this side and this side, AB is parallel to CD. Therefore angle 1 will be equal to angle 2, alternate angles, right? So instead of angle 1, we can very well write it as angle 2 plus angle 4 plus angle D is equal to 180 degree. Now what is angle 2 plus angle 4? That is nothing but angle A. Therefore angle A plus angle D is equal to 180 degrees. And what are these? Angle A and angle D are nothing but adjacent angles. So this angle and this angle, these are adjacent angles. The sum of the adjacent angles is 180 degree, therefore they are supplementary. In a similar way, you can also prove that angle D plus angle C is also equal to 180 degrees. And that's again very simple. like what we had written here, angle 1 plus angle 4 plus angle D is equal to 180 degrees. Now instead of writing angle 1 as angle 2, we can also write angle 4. This angle is equal to angle 3. So instead of angle 4, we can write it as angle 3 plus angle D is equal to 180. Now angle 1 plus angle 3 is nothing but angle C. So we prove that angle C plus angle D is equal to 180 degrees. Therefore, the sum of any two adjacent angles in a parallelogram is equal to 180 degrees. Let's move on to the fourth property of the parallelogram, that the diagonals bisect each other. So for this again we have considered this parallelogram A, B, C, D, and here again we will draw the diagonal. Now this time we will draw both the diagonals, and let us mark this point where the two diagonals meet as point O. So what are we trying to prove here? In this case, we want to prove that the diagonals bisect each other. That means the diagonals intersect at a point such that each diagonal gets divided into two equal halves. So we want to prove that AO is equal to OC and BO is equal to OD. So this is what we want to prove. So for that again, let us consider these two triangles, angle AO, triangle AOD and triangle BOC, because these are the two triangles which involve these parts AO, OC, DO and BO. And also let us name these angles. Let's call this angle 1, this is angle 2, this is angle 3 and this is angle 4. Just to make our derivation easier. Now in these two triangles, if you try to find out something which are equal, what do you see? The first thing that you see is AD is equal to BC. That's because opposite sides in a parallelogram are equal. So that's something which we already proved. Now opposite sides equal. Next thing that we see is angle 2 is equal to angle 3. This angle equal to this angle, because these are alternate angles, and we know that in a parallelogram AD is equal to BC, or opposite sides are parallel. In a similar way, angle 1 will be equal to angle 4. That is also because AD is equal to BC. AD is parallel to BC. Now, if you look at these three criteria, what do you see? That one side and two angles are equal for both the triangles. Therefore, you can say that triangle AOD is congruent to triangle BOC by ASA congruency. Now, once these two triangles are congruent, then what happens? Their corresponding parts also become equal. Therefore, what happens? DO is equal to BO and AO is equal to OC, and that is what we wanted to prove. So we can say hence proved. So therefore we very clearly proved that the diagonals in a parallelogram always bisect each other. So till now we have discussed about the properties of parallelograms. In fact, the four major properties of a parallelogram, and we have also proved them. Question number 1. Find X, Y and Z. So here we have a parallelogram. So you see only one angle is given and all others we need to find out. So do you think we'll be able to find it out? Yes, of course, because we know certain properties of parallelogram. The first property that we know is opposite angles are equal. Now since opposite angles are equal, therefore very easily we found out one angle. Y will be equal to 100 degrees. So one angle we already found out. The second property that we know is adjacent angles are supplementary. That is, sum of the adjacent angles is equal to 180 degrees. So therefore we can say that X plus 100 degrees is equal to 180 degrees, because X and 100 degree, they are adjacent angles. Therefore X will be equal to 180 minus 100, which is 80 degrees. So this is how we found out the value of X. Now what about Z? Again, Z and X are opposite angles. Therefore Z will also be equal to X, which is equal to 80 degrees. Therefore the value of X, Y, Z would be 80, 100 and 80 respectively. Question number 2. Find X, Y, Z. Here again we have a parallelogram where we have to find out these values. Now let us look at this triangle. Now, even before we look at this triangle, let us first try to see which one can we find in the easiest possible way. The value of x can be found very easily, because if you look at x, what do you see? Now, in case of a parallelogram, we know that the diagonals, they bisect each other. So the diagonals, they like cross or intersect each other such that this part is equal to this part. So in this case, first of all, let us try to name the figure. So let us call it A, B, C, D. So that would help us in our calculations. Now here we see this angle is equal to 30 degree, and let's call this angle as angle 1. So angle 1 will be equal to 3 degrees. So this is 3 degrees basically. So this is 3 degrees. So this will also be 3 degree. Why? Since BC is parallel to AD. Opposite sides are parallel in a parallelogram. So these are alternate angles. Now you look at triangle AOD, if this point is O. So in triangle AOD, what would happen? Sum of the three angles should be equal to 180 degree, that is angle Z plus angle 1 plus this angle is given as 90 degree, plus 90 degree should be equal to 180 degree. Now we already found angle 1 as 3 degrees. So 3 plus 90 would be 93 degrees. Therefore, Z will be equal to 180 minus 93, which is equal to 87 degrees. So this would be the value of Z. Now once we have found the value of Z, we can very easily find the value of Y. Why? Because Y will be equal to Z, since BC is parallel to AD. So again, these are also alternate angles. So therefore, Y will also be equal to 87 degree. So now we know Y, we know Z. So we have to calculate the value of X. Now to find out X, let us go to triangle BOC. So in triangle BOC, X plus 3 degree plus Y is equal to 180 degree. So therefore, X plus 3 degree plus y is nothing but 87 degree, is equal to 180 degree. Therefore, x is equal to 180 minus 90, which is equal to 90 degrees. Therefore, the value of x is equal to 90 degrees. So, this is how we could find out the value of x, y and z. Question number 3. Find x, y, z. So, here again we have this parallelogram. Say, let's call it A, B, C, D. Now in this case, let us see what can we find very easily. Now we know that in case of a parallelogram, opposite angles are equal. So therefore we can say that y will be equal to 112 degree, because y and 112, they are opposite angles. So we could find one value, that is y. Now let us look at triangle ABC or triangle ABD. When you look at this triangle ABD, we know that sum of the three angles should be equal to 180 degrees. So x plus y plus 40 degrees should be equal to 180 degrees. So x plus y is 112 plus 40 is equal to 180 degree. Therefore, x plus 152 degrees is equal to 180 degrees, or x is equal to 180 minus 152 degrees, which is equal to 28 degrees. Therefore, the value of x is 28 degrees. So, what is left out? Z. Now, if you look at z, z will be equal to x. That is because AB is parallel to CD. Therefore, alternate angles would be equal. So, therefore, we can say z will also be equal to 28 degrees. Question number 4. Can a quadrilateral ABCD be a parallelogram if angle D plus angle B is equal to 180 degrees? So, in order to answer this, first let us draw a quadrilateral. So, let us say this is a quadrilateral named ABC. CD. Now in the question it is given that angle B plus angle D is equal to 180 degrees. That means basically the sum of the opposite angles is equal to 180 degree. Does that mean that it has to be a parallelogram? Now quickly recall the properties of parallelogram. A quadrilateral is a parallelogram only when the opposite sides are parallel. But this relation doesn't tell anything about the opposite sides being parallel. The second property is the opposite angles are equal. But here it says that the sum of the opposite angles is 180 degree, which means that they could be equal, they could be both 90-90, they may not be equal also. Right? So there is no surety that the opposite angles would be equal. Third, the property says that the sum of the adjacent angles should be equal to 180 degrees. Again, nothing of that sort has been told in this question. So looking at only this criteria, all we can say is ABCD may be a parallelogram or may not be. So it is not necessary that just because the sum of the opposite angles is equal to 180 degree, it will be a parallelogram. But yes, had the sum of the adjacent angles been equal to 180 degree, it would have actually satisfied one of the properties of parallelogram. So in that case, its chances would have enhanced. Let's look at the second criteria. Can a quadrilateral be a parallelogram if AB equal to DC equal to 8 centimeter? That is, AB is equal to DC and AD is equal to 4 centimeter. This is 4 and BC is equal to 4.4. So in this case, it is basically saying that one pair of opposite sides are equal, but the other pair is not equal. So this will definitely not be a parallelogram. So it cannot be a parallelogram because in parallelogram, all the opposite sides are equal. If angle A is equal to 70 degree and angle C is equal to 65 degree, which clearly says that the opposite sides are unequal. So if opposite sides are not equal, then again it can never be a parallelogram. Question number 5. The measures of two adjacent angles of a parallelogram are in the ratio 3:2. Find the measure of each angle of the parallelogram. So let us assume that the angles are, let's assume that the angles be 3x and 2x. So let us assume that these would be the angles. Now as per the property of parallelogram, we know that sum of adjacent angles in a parallelogram is equal to 180 degrees. So therefore 3x plus 2x should be equal to 180 degree, or we can say 5x will be equal to 180 degrees, or x would be equal to 180 degrees divided by 5. So this would be 36. So x would be equal to 36 degree. Therefore the angles would be equal to 3 into 36 degree, which would be equal to 108 degree. And the other angle would be 2 into 36 degree, that is 72 degrees. Therefore, the angles would be 72 degrees and 108 degrees. Question number 6. The adjacent figure Hope is a parallelogram. So as you see here, this is a parallelogram. Find x, y and z. Okay, so here again, we will make use of the properties of parallelogram. So first of all, I think we will try to find out this angle. Let us call this angle 1. Now if you see here, angle 1 plus 70 degree will be equal to 180 degree, right? Because this is a straight angle. Therefore, angle 1 will be equal to 180 degree minus 70 degree, which would be nothing but 110 degree. Now, as per the property of parallelogram, we know that opposite angles in a parallelogram are equal. Therefore, we can say that x will be equal to angle 1, which is equal to 110 degree. Therefore, the value of x would be 110 degree. Now, let us talk about the other angles. Now, let us talk about the triangle EHP. Now from triangle EHP, we know x, we know 40, we do not know this angle. So if we are able to find out this angle, we should be able to find out z, because z is equal to this angle. Right? So let us call this angle as angle 2. So in triangle EHP, the sum of the three angles, that is x plus 40 degree plus angle 2, will be equal to 180 degrees. Now since EP is parallel to OH, therefore angle 2 will be equal to angle Z. So we can write it as x plus 40 degree plus Z is equal to 180 degree. Or x is 110 degree plus 40 degree plus Z is equal to 180 degrees. Or we can say Z is equal to 180 minus 150, which is equal to 30 degree. So that's how we found out the value of Z. So now what we are left with? We are left with the value of Y. So now we know Z, we know angle 1. So all we are left out with is angle Y. But do we really need to do so much of calculation to find out angle Y? That's not needed, because we know this angle is 40 degree and angle Y is equal to 40 degree. Why? Because these are again alternate angles, since EH is parallel to OP. Therefore, these are alternate angles. So this is how we could find X, Y and Z. Question number 7. Find X and Y. So here we see a parallelogram RUNS and also its diagonals which meet at a point. Let's call this point as O. And we know by property that diagonals of a parallelogram, they bisect each other. So we will make use of this property to solve this question. Now since we know that diagonals bisect each other, that means RO will be equal to ON, that is 16 will be equal to X plus Y. This is one equation that we get. Also, SO will be equal to OU, or this can be written as 20 will be equal to Y plus 7. So let us call this equation 2. Now we will solve equation 2 to get the value of Y, which is 20 minus 7, that is equal to 13. Now we put the value of Y is equal to 13 in equation 1. So what do we get? 16 is equal to X plus 13. Or we can say X is equal to 16 minus 13, which is equal to 3. So this is how we can calculate the value of X and Y. Question number 8. In the figure, both risk and clue are parallelograms. So RISK, this is one parallelogram and this is another parallelogram. They have been drawn in such a way that they intersect each other for certain regions. So some part of it is common for both the parallelograms. So we have to find out the value of X. So here again we will make use of this property that opposite angles of a parallelogram are equal. Now when you look at this parallelogram clue, so when you look at the parallelogram clue, you would see that angle E is equal to 70 degree. So angle E is equal to 70 degree because these are opposite angles. Now let us focus on the other parallelogram, that is risk. So in this parallelogram, if you see, angle K plus angle S will be equal to 180 degree because angle K and angle S, these two are adjacent angles and the sum of the adjacent angles is equal to 180 degree. So from this, angle S will be equal to 180 degree minus angle K, that is 180 degree minus 120 degree, which is equal to 60 degree. So now if you look at, let us call this point as point O. So now if you look at triangle OES, what do you see? You know angle E, you know angle S. So all that you need to find is S, X. So we know that sum of three angles of a triangle is equal to 180 degrees. So here let's put the value of angle S, which is 60 degree, angle E, which is 70 degree, and this is equal to 180 degree. Therefore X is equal to 180 degree minus 130 degree, which is equal to 50 degree. Therefore, the value of X would be 50 degrees. Question number 9. Find the measure of angle P and angle S if SP is parallel to RQ. So SP and RQ are parallel. So let's see what would be the measure of angle P and angle S. Now just before we go ahead with the problem, can you tell me if this is a parallelogram, the PQRS which you see on the screen? This is not a parallelogram because not both pairs of opposite sides are parallel. Only one pair of opposite sides are parallel. RS is not parallel to PQ. Therefore, this is not a parallelogram. So, can you tell me which type of quadrilateral is this? This is nothing but a trapezium because one of the pair of sides are parallel. So, this is a trapezium. So here what do we see? We see that this angle is given as 130, this angle is given as 90, and it is mentioned that SP is parallel to RQ. Now when these two are parallel, so if this is 90, so this would also be 90. So if this is also 90, this entire thing is 180, so this also has to be 90. So therefore angle S will also be equal to 90 degree. Now we know that the sum of the four angles, interior angles in a quadrilateral is equal to 360 degree. So we can say angle P plus angle Q plus angle R plus angle S. All the interior angles, their sum would be 360 degree. So P is not known, Q is 130, R is 90, S is also 90. So this is equal to 360. So therefore, this comes out to be angle P plus 310 degrees is equal to 360 degrees, or angle P is equal to 360 degree minus 310 degree, which is equal to 50 degrees. So therefore, we could find angle P as 50 and angle S as 90 degrees.
I hope you found this video useful. If you really liked the video, do not forget to share it with your friends so that they can also benefit out of this video. I will meet you guys very soon with a new video on a new topic. Till then, take care. Bye-bye.